Hi, and welcome to Exponents and Scientific Notation. This is lesson 15.1, the guided practice. We'll get started here with the very first one, x to the negative first power. Now, if you didn't see my video on negative exponents, I'd like to give you a little bit of information about this stuff here. If you have x, let's just say you have x to the first, x, 8 to the first power. That is just 8. And 8 to the second power, that is 8 times 8, which is 64. And you could have 8 to the third, you can keep on going with this. That's 64 times 8, which is 512. Now, we can go down as we have 3, 2, 1. We can go x to the 0, 8 to the 0. 8 to the 0 power, well, let's take a look at this. If we have the patterns, this 512 divided by 8, every time you divide by 8 is 64. And 64 divided by 8 is 8. So to keep going with this, you would divide by 8 again, and 8 divided by 8 is 1. Any number to the 0 power is 1. But we need to go to this, 8 to the negative first power. And to do this, we would keep on dividing by 8. If you divide by 8 again, that would be 1 divided by 8, or 1/8. And that's what this is here, 1/8. Now, the next one, I'm going to move this over a little bit, is 6 to the negative second power. I'm going to spend just a little bit of time explaining this one, and then you'll see what's happening here. So I'll erase this. And let's go 6 to the second. That's 6 times 6, which is 36. 6 to the first, that is just 6. And 6 to the 0, well, that's 1. Any number to the 0 power is 1. And take a look. You would divide by 6 each time. And 6 divided by 6 is 1. Okay, so 6 to the negative first power is divide by 6 again. That would be 1/6. And 6 to the negative second power, you would have to divide by 6 again. Now, 1/6 divided by 6 is 1/6 times 1/6, right? Because this, you have to turn it to multiplication, and you have to flip that fraction. And I could make it a fraction right here. That's 6 over 1, and when you flip it, it becomes 1/6. Now, 1/6 times 1/6 is 1 over 36. And that's what this is. It's 1 over, it's 1 over 36. See, and hopefully you can see this relationship like that. 6 to the second power is 36. But 6 to the negative second power is 1 over 36. And that's what we should have right here. Right here. Okay, let's get into anything to the 0 power. I told you is 1. All right. Next, we have 10 to the second power. That's 10 times 10, and that is 100. 5 to the fourth power. That's 5 times 5 times 5 times 5, and that is 625. Number 6, 2 to the negative fifth power. Let's go back over this. To answer that one, let me show you this. If I have this, then let me erase the things that are not all that important right now, so I can show you something that is very important. So what we have here is this right here, 6 to the negative second, that's the same thing as 1 over 6 to the positive second, because 6 to the second power is 36. Now, if I were to make this, if I were to expand this, if I have 6 to the third, that's a bigger number. 216, I think, could be. Let's see. Well, 36 times 6 is 6, 18, yeah, 216. So it's 216. So 6 to the negative third power is going to be 1 over 216, which is 1 over 6 to the third. You see that relationship is developing here. And I'm going to highlight it with these right here. Oh, goodness gracious. You got to be kidding me. I can draw better lines than that. Okay, so that's super important, and I'm going to use that for this one here. This one. This is equal to, so 2 to the negative fifth is equal to 1 over 2 to the fifth. And 2 to the fifth is, I think, 64. So this would be, oh, it's 32. So 2 to the fifth is 32. And so, see, this is equal to 1 over 32. Next, we have 4 to the negative fifth. So 4 to the negative fifth, 4 to the negative fifth is going to be equal to 1 over 4 to the positive fifth. 4 to the fifth is 4 times 4. It's 4 times 4 times 4 times 4 times 4, which is a huge number. Let's see what that is. 1024. So if you multiply 4 times itself 5 times, you get 1024. Anything to the 0 power is 1, okay? And 11 to the negative third power, well, that's going to, 11 to the negative third power is 1 over 11 to the positive third power, which is 1 over 11 times 11 times 11. Is it 1221? I think. So 1331. Yeah. So there you go. Okay. Now let's go to number 10. This is going to be easy. It's you have 1, 2, 3 of them, so that exponent here should be a 3. And let's see. For this one, I have 1, 2, 3, 4, 5. I have 5 of them. So actually, so that's going to be a 5 at the end. That's going to be a 5. And what do they mean? What's going on here? 2 to the second. So that's 2 to the second. That's going to be a 2. And times 2 to the third, 1, 2, 3. So that's going to be a 3. Is 2 to the fifth. And that easy thing that you can do is you can just add 2 and 3 is equal to 5. That's the multiplying by power rule. 2 to the second times 2 to the third is 2 to the fifth because you add your exponents. This one, 6 to the seventh. Now, 6 to the seventh, you have 1, 2, 3, 4, 5, 6, 7. And 6 to the fifth is 1, 2, 3, 4, 5. And what you can do with this is you can cancel. These get canceled, these get canceled, these get canceled, these get canceled, those get canceled. And your base, the base right there, the 6 is called the base. Base is 6. And you have 2 of them, so it's to the second power. And this one. So let's bring it back to this here. You hopefully might see that the shortcut is you just subtract those exponents. 7 minus 5 is 2. That's because you have 7 on top and 5 on bottom, and you have 2 more on the numerator than you do in the denominator. And that's what we bring to this here. So we have the 12 minus 9. That's going to be 12, and that's going to be 9. 12, 9, and 12 minus 9 is 12 minus 9 is, oh, wait, 3. 12 minus 9 is 3, and that base is 8, 8 to the third power. 5 to the 10th, well, let's see. We have 10 of these, and then we have an 11 and a 12. We have 12 5s being multiplied, so this is going to be to the 12th. Maybe I won't. Maybe, yeah, I'll explain that one a little bit more. So 5 to the 10th means you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then these two, I'll put in blue, times 5 times 5. And altogether, I should have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 5 to the 12th. And this one, 7 to the 8 times 7 to the 5th, that shortcut is you have to just add the exponents. Because you have 8 of these and you have 5 of those, and so together you should have 13 of the 7s. So this would be 13, and the base is still 7. Now, this one's a little bit different. This one, you would have 6 to the second. I'll put it in parentheses. 6 times 6. That's this part right here. In the parentheses, that's 6 to the second. Now I have to take it to the 4th, which means I have to repeat this 4 times. So I have, here's 1. 6 times 6. There's 2 of them. I need 3 of them altogether. So I guess I have to repeat it 3 times. 6 times 6, there's to the 3rd, and 6 times 6, there's to the 4th. Now, how many 6s do I have? The base is 6, so there's 6 right there. And then how many do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 of them, so there's going to be an 8 right here. But how can we get there? Well, you could see that you could multiply 2 times 4, which is what will be right here. Okay. 8, let's see what we can do here. So 8 times 12 to the 3rd power, you could separate them. It could be 8 to the 3rd times 12 to the 3rd. So that's what's going on right here. 8 to the, that could be, wait, 8 to the 3rd, 12 to the 3rd. Let's see what else we got here. We have this one. Now, this one takes a little bit of thinking here. So let me bring this out over here and explain this one a little bit more in detail. So 6 to the 9th. 6 to the 9th is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's 6 to the 9th. And I'm going to try to make this a straight line. Yeah. And then I have, oh, come on now. I don't want that. Okay, yeah. And then over 6 to the, now 6 to the 0 is 1, but this one right here, 6 to the negative 10th, remember 6 to the negative 10th is equal to 1 over 6 to the positive 10th. So all of that goes into the denominator over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we can cancel all those 6s that are in common in the numerator and denominator, and you're left with this, which means we have equals 1, 1, because there's nothing left on the numerator. There's nothing left here. You need something there, a 1, over 6, right? Because that goes right there. So it's 1/6. That's the answer. I will do this. 1/6. And then we have this one. I will copy this and bring it over to a blank spot right here. So for this one, 10 to the second. 10 to the second is 1, 2 times 10 to the 7th. You know what? I'm going to do that in a different color. 10 to the 7th. 1, 2, 3, 4, 5, 6, 7. And then we're going to have this all on top of 10 to the 5th. And I'll put 10 to the 5th in a different color. 10 to the 5th, 1, 2, 3, 4, 5. And then we can cancel all the stuff that can cancel. 1, 2, 3, 4, 5. And what we're left with is 10 to the 4th on the numerator. So that's equal to 10 to the 4th. So let's see. Let's see how good I am. Ah, and of course, 10 to the fourth. 10 to the fourth is equal to 10,000. It's a 1 with 4 zeros after it. Okay. Next, let's get this one here and bring it over. I'm going to slide this over here and then zoom in. So let's see. I will do the order of operations. Remember, the order of operations, PEMDAS, parentheses first, and I can do 10 minus 6, which is 4 to the third, and then I'm going to write down all the rest of the stuff. Oh, and I can do these parentheses. That's 10 plus 2, which is 12 to the second. Okay, now I'm going to do all of my exponents. Okay. So I was just thinking for a moment. So 4 to the third times 4 to the second. 4 to the third. 4 to the third is 4 times 4 times 4 times 4 times 4 plus 12 times 12. I know that 4 times 4 times 4, that's 64 times 4 times 4 is 16, plus I know that 12 times 12 is 144. Now I need to do 64 times 16. And 64 times 16 is 1024 plus 144. Let's see, that's going to be 8. That's 6. That's 1. 1168, I believe, is what our target is. So let's see how I did. 1168. And now we have this one. Ooh, boy, there's a lot in there right now. Right here. And I'm going to zoom this out, bring that over. Let's see. Okay. 12. I'm just going to jump right in and have the... I like to have a nice straight line when I do this. So I have 12 minus 5. 12 minus 5 is 7. 12 minus 5 is 7 to the 7th power. Oh boy. 7 to the 7th power is a big number. And then that's over, what, 3 plus 4. I got to do 3 plus 4, which is 7 to the 2nd power. Oh, okay. So this is going to be 7. Oops. It's going to be 7 to the 2nd power, and I'll put these right here to the 2nd power. And then this is going to be 7 to the 7th over. Now, what I could do is I could multiply 2 times 2, which is 4. And so it'd be 7 to the 4th. Okay. Now, oh, I made a wee bit mistake right here. I have this right here. That should have been to the 7th. Because I just got done saying how big that number is. Now what we can do is we could do 7 as our base, and then we could subtract 7 minus 4. And when I say subtract 7 minus 4, let me be a little bit more clear with that. I'm saying this was the 7, so you take that 7 right there. 7 minus 4. And then what we have is 7. 7 minus 4 is 3. That should be 7 to the 3rd. And I happen to remember that I think that's 343. So the answer is either going to be 7 to the 3rd or 343, because 7 times 7 times 7, right? That's 49. 49 times 7 is 343. Don't ask how I know that. So that's what we're looking at for this. And here I'm going to remove that 343. Okay. So what do we got here? Summarize the rules for multiplying powers with the same base. dividing powers with the same base and raised power, raising, all these, summarize all these rules. Well, here you go. Here is a summary of all these. Uh, when you're multiplying powers with the same base, you add the exponents. Just to let you know, that's what I did. That's what I did on number 14 right here. I added the exponents. We could do that. We could say I did that there, or right here too. On this one, adding the exponents, or adding the exponents right here. 2 and 3 is 5. When dividing powers with the same base, you subtract the exponents, and that's what I had done actually on the last question over here. That's what I had done right here. I subtracted the exponents because I was dividing powers with the same base. The same base was 7. And when raising a product to a power, you raise each factor to that power. That is related to this one right here. Each factor to that power. So you split them up and raise each factor to that power. And there you go. That is the entirety of this lesson here. I hope that you found it useful. Thanks for watching.